Okay, so if you look out into our corner of the universe, the Andromeda Galaxy is the undisputed heavyweight champion. It's huge, it's majestic, and right next to it you'll see this tiny little smudge of light, a companion galaxy called Messier 32. For the longest time, we all thought we knew its story. It was just there, a small, simple satellite. But what if that open and shut case is anything but?
Yeah, what if this tiny, unassuming neighbor has been hiding a massive secret? A secret that could completely change how we think about the way galaxies live and die and, interact with each other. Well, that's exactly the cosmic cold case we're digging into today. So, this is our subject, M32. You can see it right there, basically sitting on top of Andromeda's giant starry disk, and that makes it incredibly difficult to get a clear look at. It's like trying to study a firefly that's hovering in front of a stadium light. So since the 1940s, the official story has just been that it's a small, boring, dense little galaxy, forever tied to its giant neighbor.
Right, so this idea that M32 was just a simple satellite made it the perfect example, the poster child, for a really rare type of galaxy we call compact ellipticals. Now, these things are fascinating. They're tiny, but the stars inside are packed together incredibly tightly.
So let's lay out the official file, the story that's been accepted for over 70 years. 1. M32 is a satellite of Andromeda, which means we assume it's at the same distance from us. 2. The reason it's so small and dense is because of something called tidal stripping. The idea is that Andromeda's gravity is so powerful, it's literally ripped away M32's outer layers, leaving just this dense core. In fact, some astronomers even call it ARP 168, which is a catalog for weird, peculiar galaxies, specifically because it looks like it's been roughed up by gravity.
Okay, but this is where it gets really good, because the more astronomers looked, the more the official story just didn't hold up. They started finding clues that pointed in completely opposite directions.
And here's the puzzle in a nutshell. On one side, you have the Hubble Space Telescope, which is so powerful, it can actually see individual red giant stars inside M32. That's a huge piece of evidence that it has to be close by, right where we think it is. But then you look at how fast the stars in its core are moving, and it's just way too fast for a tiny dwarf galaxy. Not only that, but other measurements, using things called planetary nebulae as distance markers, hint that it might be more than twice as far away. How can both of those be true?
Let's just focus on that speed for a second. The stars in the middle of M32 are whipping around at an average of 72 kilometers per second. That's really fast. For comparison, Andromeda's other little companions, they're cruising along at a chill 20 kilometers per second. M32's core is moving like it belongs to a much, much bigger galaxy. It's a total anomaly.
I love this quote from a research paper back in 2008. It just perfectly captures the frustration. You've got two scenarios that can't both be right, but both have evidence against them that seems like a total deal breaker. It is, quite literally, a cosmic whodunit.
So every good mystery needs a list of suspects, right? Well, in the case of M32, astronomers have come up with three main theories, three competing stories that try to explain what this thing really is. Okay, suspect number one is the classic theory, the one that got it, that ARP 168 peculiar galaxy label. The idea here is that M32 wasn't born small. It used to be a much larger normal galaxy that got too close to Andromeda, which then tore it to shreds, leaving behind just this dense, fast-moving core. It's a story of galactic cannibalism.
Now, suspect number two is the wild card, the radical idea. What if this is all just one big cosmic coincidence? This theory says M32 isn't a satellite at all. It's a perfectly normal, medium-sized galaxy that just happens to be way, way in the background. But from our perspective here on Earth, it lines up perfectly with Andromeda. If it's farther away, its high speed makes total sense. But that completely contradicts what Hubble is seeing.
And then there's suspect number 3, which basically says we've been calling it the wrong name this whole time. When you look really closely at how its light is distributed, it doesn't look like a simple elliptical galaxy. Instead, the data fits perfectly with a model of a galaxy that has a central bulge and an outer disk. You know, the structure of a lenticular galaxy. If that's true, M32 isn't the prototype for compact ellipticals. It might mean that whole category of galaxy doesn't even exist.
So, we have three suspects, three totally different stories. How do we figure out which one is right? Well, we need more clues. We need to bring in the forensic team. And for astronomers, that means things like the Hubble Space Telescope and incredibly powerful computer simulations. And a huge new clue just dropped in 2023 from a Hubble study. Astronomers decided to go looking for a very specific type of star, called a carbon star. Now, based on what we know about the other stars in M32, there should be plenty of these. So the question was, would they find them?
And the answer added a whole new twist to the mystery. They found thousands of normal M-type stars, just as expected. But carbon stars, they only found 57. And when they looked closer, they realized pretty much all of those were probably just foreground stars from Andromeda itself, contaminants in the data. So for some reason, M32 is mysteriously missing its carbon stars.
And these images show you exactly why this detective work is so hard. On the left, that's what you see when you look at M32. On the right is a patch of sky right next to it, which is just the background of Andromeda. I mean, look at that. The M32 field is so incredibly crowded and polluted with Andromeda's stars, trying to figure out which star belongs to which galaxy is a Herculean task.
So other scientists have tried a different approach, computer simulations. One model tried to recreate a scenario where M32 literally plunged right through Andromeda's disk about 800 million years ago. And what's cool is that impact could actually explain the giant ring of new stars we see in Andromeda today. But here's the bombshell from the simulation. Even with that direct hit, stripping stars off of M32 was, and I quote, inefficient. This suggests that M32 might always been small and compact, not stripped down by its neighbor.
So you've got all these new observations, all these simulations, all this analysis, and where are we? Well, the truth is, the case of M32 is still wide open.
Let's look at our evidence board one last time. The stripped dwarf theory feels right. It explains why it's so close to Andromeda, but the simulations say stripping just doesn't work that well. Then you have the background galaxy theory. It explains that crazy high velocity perfectly, but it just can't get around the fact that Hubble can see its individual stars, which means it has to be close. And finally, the lenticular galaxy idea. It fits the light profile like a glove, but if it's true, we have to rethink an entire category of galaxies. Every single theory has a smoking gun pointing at it, and a rock-solid alibi.
And you might be thinking, okay, it's one small weird galaxy, why does this matter so much? Well, it matters because M32 is right in our backyard. It's our closest laboratory for seeing what happens when a small galaxy gets too close to a giant. Figuring out its true story, was it a victim, was it born this way, is it an imposter, is absolutely fundamental to understanding how all galaxies, including our own Milky Way, grow and evolve.
So, the question is still on the table. Is M32 a galactic victim, beaten down and stripped by its huge neighbor? Is it a cosmic illusion, a normal galaxy in the background playing a trick on us? Or is it something else completely, the key that could unlock a whole new chapter in the story of galaxies? For now, this cosmic case remains unsolved.